Hello everyone. Welcome back to another flip lesson. Today we're going to talk about perfect squares and square roots. So we've already had a lesson on exponents, so you should be aware of what an exponent is and how it is a short form of a multiplication problem. And now we're going to look at certain kinds of exponents, which are perfect squares, and then we're going to undo those perfect squares by taking square roots. So as usual, we need to complete the review it section. So if you haven't done so already, pause the video, complete this section. This will give us a reminder of what exponential form is and how to do expanded form and simplified form of exponents. So now that you've completed the review it section, let's see what we need to know for perfect squares. So we're going to explore perfect squares, figure out what that means. And as I said earlier, perfect squares are just a form of an exponential form. So it is going to have a base and an exponent, and it's just a short form of a multiplication problem. Perfect squares are numbers. Remember that they are numbers made by multiplying. So we are going to be multiplying the same whole numbers together. So perfect square is an exponential form, and its exponential form is multiplication, and we're multiplying the same whole numbers. So looking at 12 to the second power, first of all, let's label our parts. The 12 is the base, and the 2 is the exponent. It's also called the power. And so when we talk about a perfect square, again, it's an exponential form. So really all it is the short form of a multiplication problem. Well, what multiplication problem does this represent? 12 times 12. And 12 times 12 is 144. So because I can take 12 times 12 and I get 144. 144 is a perfect square. We can read this as 12 to the second power, or we can read it as 12 squared. So let's explore this perfect square concept. Just keep in mind it is just an exponential form, but let's look at it in terms of perfect squares. So we're going to look at all these perfect squares. Well, what makes a square a square? One of the things that we have to remember is a square has the same length for all sides. All sides are equal. So looking at these, we are going to figure out whether all sides are equal. If they are, then we have a perfect square. So let's shade first. We're going to shade each perfect square diagonally. Diagonally means at an angle. So I'm going to shade it at a diagonal. And then I want to find the length of that diagonal. How many boxes did I shade in? 1, 2, 3. So the length of the diagonal is 3 units. And then I want to find the length of each side. 1, 2, 3. So this side is 3. 1, 2, 3. This side is 3. 3 and 3. So each side is also 3 units long. So we know that a perfect square is going to have the same diagonal length and the same side lengths. So let's try it on the next box. Let's shade the diagonal. And so our diagonal has a length of 4 units. And all the sides are 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Looks like all the sides are a length of 4. So it is a nice perfect square. Let's try one more. Shading on the diagonal. How many did we shade? 1, 2, 3, 4, 5, 6 units. And each side is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So each side is going to be 6. So that's another perfect square. Now we use this information to help us find the area of squares. And since we know that a square has the same length on every side, it's very easy to find the area. When we talk about area, we are talking about how much space does that square take up. In other words, how many of these squares does it take to fill up that box? We could easily count the squares right here to figure out how much area it has, but let's look at it in another way using perfect squares, using exponential form. So I want you to look down here at the bottom, skip over these lines, and we're going to look at the area. And we're going to look at a formula, which is a rule in order to find the area of a square. The area of a square is found by taking one side and multiplying it by the